Hello and welcome. This is register number URK17CS183 and today I will be demonstrating our lab experiment number 2, uh, queues and normal queue and circular queue. So let's directly jump into our first program. So as you can see here, I have created a class named queue, and in private variables I have my n as a pointer type, which will be going to work as array for us, and we have the front and rear as we have in real life queue, and we have this thing that's called a size of queue. So we have this following methods inside this function as queue, which is going to initialize the value. Then we have nq for inserting, dq for removing or reducing the values from the queue, from like similar same thing, and peak is going to return the most which is like in the most front, that value, and the size is going to return what is the current size of the queue, and is empty and bool is full. This bool types variables is going to methods is going to check if it's empty or is full, and we have created a destructor inside the class to freeze the memory. So let's see our first program. So in capacity we are passing whatever are the size of the queue to our n pointer variable, and we are initializing front and rear. So at starting there is nothing, so everything is becoming -1, and capacity is basically our size of queue, will be whatever the amount we can put it inside a queue. And now we are checking if it's full. So basically if rear equal to size of queue -1, so obviously if the value of rear reaches the value of whatever the size we are passing, it will be become full, and that's why it's returning true. Is empty is simply front and rear is -1. As you know the initial conditions, it is easily we can say it's empty. In nq we can see the conditions, so we are checking if it's empty or not. So if it's empty, we are giving the index location of 0, and we are putting the our value inside that using the rear index value, because both are same, so it doesn't matter. Or else we don't traverse, the front stays always in the most front. Obviously the second one, the rear keeps on going back and back, so the queue follows the first come first out policy. So whatever came first, it will go in the first place. So according to that logic only, rear keeps on increasing and it keeps on going to the back. And this peak is simply returning whichever value is in the most front, as I have said, because it's in the most front value, it's the peak. Whatever if a person takes a look of a queue, he can see the first person who is standing in the most front. Okay, and for dq we are checking if front equal to rear. That means there is nothing in the queue. Front and rear are joining, means basically there is nothing. So either the things already everything have been popped out, or there was nothing at from initial time. So with that condition only, we can conclude that front and rear equal can be assigned as -1 again, so that it can be reinitiated everything. Or else we'll do front plus plus. So dq means whatever is in the front, if we came one next node after that, so whatever is in the back will be ignored completely. And this is returning the size of the queue. So whatever the size, if the front keeps on increasing, we will reduce it by minus rear, and we will increase 1, so that we can get whatever the value we have. Suppose so we have if 3 is the size of queue and front is at starting location, then we have the size as 3. But if front increases by 1, then we have the size as 2. So to follow that up logic, we created this algorithm, and simply we are calling here this particular destructor to free up the memory space. Now in inside main, we have called this all values as nq, and we have used all these other operations to show and how all methods are working. So let's run and see the program. So as you can see here, so you'll be able to see first of all, let me make it clear so it will be easy to understand. So I'll put a few end lines here, it will be easy to understand. Okay, so now let's see our output again. So let's see, we have put here as queue size as 5, and we are giving value 87421. So it's simply asking the size is 5, the output is right. Peak means the value we put at the most last. So it's giving us, sorry, first we are doing DQ operation. I missed this one. So we are doing first DQ operation means the last value, the first value that we put was 8. So we are doing DQ. So 8 is removed. So the most peak value is 7 now. So we are getting 7 as output. And then we are here giving again DQ and Q peak. So now it's 4. And again DQ and Q peak. And it's giving 2. And C out we are giving Q dot is empty. So when there is nothing, so our empty function is returning 0. So we are getting here output as a 0. Now let's go to our next program. Our next program is a circular queue. It's almost as same as our normal queue, but the only difference here is when in normal queue the size gets finished. Suppose we are passing any value as 5, and if it gets finished at the end of, we keep on popping and front and rear comes like equal, then we can't insert. It will show as Q is full if we don't reinitialize the value of front and rear is equal to -1. But if in circular queue we can directly start assigning the rear after, if the front is popped out, those locations we can reinitialize without giving a condition of rear and front equal to -1 again. So let's see in this program. In private we have declared two variables, SCQ in front rear, similar to the previous one. And in public we have declared all the functions inside other than going outside the class. So as you can see in this queue we have rear front equal to -1 initializing, passing this value as dynamic array inside this pointer type. Now inserting this thing, we are checking if front equal to 0 and rear equal to max -1, or rear equal to front equal to rear plus 1. So these two conditions we have for checking if queue is overflowing or not. So these are the only two conditions. And if front is in the initial location and max is in the last location, means rear is in the last location, that's the only condition when it will show queue is overflow. Or front is equal to rear plus 1 means it's following the same condition, but this is the algorithmic version of this condition, and only those conditions will show queue is overflow. Other than that, if front equals to -1, then it's like the condition, the queue is already empty. We can start with new assignments and variables. And else, this is the condition, if rear is equal to max -1, then we will assign rear equal to 0. So this condition is giving the rear again whatever the value is. If it's in the end point, it will restart the rear and start assigning it. Or else there is one more condition, it will give the increment to rear wherever it is, and it will assign a new value. And whatever the rear value becomes, it will assign the item to that. This is for doing the insertion. Let's see for deletion. So the same logic we are following here, but instead of rear we are putting front. Let me explain how. So we are checking if front equal to -1. So if there is nothing in the queue, will be nothing to delete. So it will show queue is underflow, or else it will show element deleted from queue is, and we are giving the whatever the element is deleted. And if front is equal to rear means both are like joining each other. So similarly we are reinitializing it to -1 as we did in previous queue. Else if front equal to max -1 means it reaches the end of location by popping, so we'll assign front equal to 0, so that front comes again in the front. That's what circular queue does. It keeps on rotating itself. It doesn't every time it goes out, so that we have to reinitialize value like here. But there is a condition where we can just keep on traversing still inside the queue if the locations are freely available. And to display it simply, we'll check if it's empty or not, and or else we can simply start while loop from front till rear, and we keep on printing it and keep increasing the front. Or there are a few conditions else to check, and according to that we work. And here I again created a while loop and a switch not a while loop, a switch case to check all the conditions. So let's run the program and see. So let's see our first program. I'm inserting an element. I will insert the element. Okay, now let's display our okay, so I deleted from queue a value. Okay, let's display now. So we have only one value, as you can see. So here I have input a value, input the element for insertion queue. So I have entered 5, and again enter your choice. Again I have given the input as 2, an element deleted from queue again 2, and as you can see our program is working successfully. Let's put this thing. So now I've come out of the switch conditions. So we have successfully completed our second program. Thank you so much for watching.